Hi again, everyone, and welcome to our final session of OmniTestingConf before the closing roundtable discussion. In this presentation, you'll hear from Jon Seaton, Director of Data Science at Functionize. Jon will share how machine learning can boost software testing and how you can take advantage of machine learning to boost your test automation with the Xray and Functionize integration. As you already know, you can ask questions through the Ask a Question button, and after the presentation, we'll again have a 15-minute Q&A where Jon will answer all of your questions. And now I'll pass it over to Jon.
Can you see my screen? Okay, very good. Hi, so my name is Jon Seaton. I am the Director of Data Science and Machine Learning at Functionize. And today I am going to talk to you guys about how we use machine learning in our software testing framework, and also how we've integrated Xray into our software testing framework as well. So let's get started. A little bit about Functionize. So Functionize is an AI testing platform. We primarily run tests, end-to-end tests in the cloud, although we do also have an on-prem version as well. We typically focus on functional and visual testing, and the objective is to reduce maintenance, increase speed in which you can create tests, and things like that. The company was started about 6 years ago now in 2015. This is just a look at some of our current customers we have now. We've been growing quite rapidly. We raised a Series A last year, which was quite significant. And we've been growing very, very quickly since then. So that's sort of a high-level overview of the company. So one of the reasons why Functionize started was because we noticed there was an issue with QA and how QA could keep up with the ever-expanding complexity of software. So, and one of the things I noticed prior to joining Functionize was the fact that you had ever more complex software being created, but the testing of that software has had a difficult time keeping up. And so what we thought is what if we could apply AI and sort of using big data analysis to actually help in improving that QA and software development lifecycle. So that was really the motivation for why the company got started, was we noticed this gap in between where you might expect software to develop in more of a linear fashion, but in fact it develops more exponentially. And so you have this surprise factor in which you have to account for, right, in both your development and testing. So that's sort of the motivation why the company got started. So what are some of the modern challenges with test automation? First one is release velocity. Of course, like I said before, software is getting more and more complex, and you want to release that as fast as possible. And it's difficult for a lot of testing frameworks to actually keep up with the speed at which software is developed. The second is that software has frequent changes. And what that means is, in terms of maintaining those tests, especially if you're using tools like Selenium, can be quite a challenge, right? Because the stability of your XPath and things can break quite easily when the software updates. And then also maintaining that test debt. So you have to go in and fix all of the tests that do break when you have new releases. And what we found was from some of our customers was about 60% of the time QA teams are actually spending just maintaining tests alone, right? So they'll create your tests for the release, then the next release comes, and a lot of their time actually ends up going into maintaining those tests and that test debt. So Functionize, basically, we have a platform that aims to solve that problem. So let me talk a little about the Xray Functionize integration. So what we've created here is basically the ability to have your tests, manual tests defined in Xray that are ready to be automated. We can then import those into Functionize, where you can use a tool such as our architect to actually build that test case. This requires no scripting at all. All you do is you go through the test workflow, and we will actually create that test for you. You don't have to really think too much about it. You just go step by step, and we will record all the information needed to build that test. We then will run that test in our cloud. We have a Functionize test cloud that can run on all kinds of different platforms. We support all browsers, Chrome, Firefox, Safari, and also mobile as well. So then you can run those tests in our cloud. We keep track of how to maintain those tests when you have new releases, things like that. That's part of our ML engine, which I'll talk about in a second. And then once that's done, then those results are then sent back to Xray, which you can then track and do reporting on. So this is sort of what we built here with Xray, and I think it's really exciting to see this integration. Some of the benefits here is basically rapid test creation. So you don't have to worry about scripting tests for automation. You can use our tools to create tests very quickly, and you don't have to be an expert in coding or developing. You can be, we've seen people that have no coding background at all create tests, in 5-10 minutes, very, very fast, very simple, and they work, right? So that's great. The other advantage is our self-healing, powered by our AI or ML engine. Basically, this is the part of the system that keeps those tests maintained. So as your software develops, our ML is able to look at those changes and basically proceed with those test workflows in a way that a human would. So basically simulating human thought in terms of how manual testers would actually proceed with the test case, even despite maybe major code changes in your release. The other advantage is reduced infrastructure overhead. We support all of the cloud infrastructure ourselves. So you're basically relying on our cloud infrastructure, which is built on Google itself. So it's very reliable, very, very good. And also increased visibility, right? So being able to integrate with Xray, you can see those results and do that reporting that you would normally do, which is great. And so basically, these are the main benefits to this Functionize and Xray integration. So we're really excited to work with Xray and work on this project. So I think this is going to add a real benefit to the QA industry for sure. Okay, we're going to talk about a little bit more about the technology. I wanted to talk about how at Functionize we built our ML, or at least thinking around how we use machine learning in testing. If some of you maybe are not familiar with this concept, machine learning is basically a set of techniques used to achieve artificial intelligence. So when we think of artificial intelligence, it's a much broader term. Machine learning is specifically around how we use techniques with computers, things like that. So one of the objectives is to be able to create an algorithm that can actually adapt given a set of data inputs, right? So you can create an intelligent software, right, by hard coding or defining the logic in a manual way. But what's really cool with machine learning is you can actually automatically build that code, build that model without explicitly programming anything, right? So the model is actually learned from examples or from data. And this is really cool because you can actually analyze much larger data sets with machine learning than you could ever do, as a human, right? So that's just a little overview definition of what it is. And so some of the different methods we use three main methods: supervised learning, unsupervised learning, and reinforcement learning. So for those not familiar, supervised learning, this is building a model from labeled data set. So for example, a common example is in image detection. You have an image, and maybe there is an animal in that image. Maybe there's a cat, and you label that image as cat. And maybe you have another image with a dog, and you label that image as dog. And that's the input into your model. It's the image plus the label. So that's an example of supervised learning. Example of unsupervised learning, you have unlabeled data. So basically, maybe you have a time series or something, a set of data points over time, and you want to cluster that into groups of maybe similar behavior. So you don't necessarily rely on a label. You actually try to make that association yourself by measuring some type of a distance metric or something, right? So that's an example of unsupervised learning. And then in the case of reinforcement learning, you're building a model to maximize a reward. So common example is when you're playing a game, for example, like chess, or some game where you can measure a score, right? So the computer goes through all the different combinations and based on previous experience and learns what is the best move to make to maximize my score. So that is an example of reinforcement learning. So there's different kinds of supervised learning depending on what type of data set you're looking at. So there's the case of continuous data. Continuous data, for example, could be over time where you have a variable that has no discrete segments. And in that case, this is called regression analysis. In the case of you have discrete data, like I said before with like cats or dogs or something, that's a discrete data set. That is an example of classification. So you're trying to classify that data based on those discrete categories. In the case of unsupervised learning, we don't really know what the data is, if it's continuous or discrete. And this is an example of clustering. So that would be called clustering. So for example, like I said, you have a set of data points and you're trying to associate them and cluster them into similar groups. In the case of reinforcement learning, you can also have discrete data. And in this case, that would also be considered classification. But in the case of in which you don't know the actual data distribution, this would be called control or a control system. So we use all of these different ideas when we build the machine learning models in Functionize. So what are some of the challenges to machine learning? There are three main challenges that we usually see. First is accuracy. How accurate are your models? And there is a trade-off between bias and variance of the model. And I'll talk about this on the next slide, but basically you can end up with a situation in which your model is overfit or underfit to the data. Both cases are bad, and you have to try and balance the difference between these two, depending on what your application is. The other challenge is the curse of dimensionality. So like I said before, when you're doing big data analysis, you can have very high dimensional data. And the higher dimensions you have, the more challenging it becomes to actually build machine learning models because your sampling rate becomes sparse, right? So if you have a lot of dimensions, maybe you have 100 or 1,000 dimensions, the sampling rate in that space, that high dimensional space, is relatively low. And the models cannot learn, with high accuracy in high dimensional spaces as well. So what we typically do is, in order to solve this problem, we have to use dimensional reduction processes, right, to actually try and map high dimensional spaces to low dimensional spaces. But it still is, it's not perfect, and it can be difficult sometimes. So that's another big challenge that we see. The other challenge is scalability and performance. This is not as big of a problem because we utilize, cloud computing, and we're able to spin up VMs when we need. But this can be an issue depending on your application. If you want real-time analysis and things like that, being able to build complex models that scale and perform well can also be quite challenging. So these are main challenges that we see in applying machine learning to any application, not specifically for us, but for all applications of machine learning. So let me talk a little bit about the bias versus variance. So bias is error introduced in the model from underfitting. So basically what happens is you have a small subset of data, and that data is biased or not exactly a good representation of maybe the full data set you might see in a production environment, right? So so this is an example of underfitting. So there's some assumptions in how you built your model that make it, when you actually take that trained model and put it into a production to actually test it and use it, it doesn't perform well because it's underfit. Your training set was not good, or your model assumptions were not good, right? The other case that can happen is you can have variance, and this is the case of overfitting. So this is very common. We see this all the time, where we'll take a data set and we'll train a model and we'll get like 99.9% accuracy, right, on that data set. Well, what happened is we basically just mapped that training data, the model learned exactly that training data. And then if we send it a new data type that we've not seen before, it will fail, right, because it's overfit to that initial training set. So what we have to do is we have to balance these two cases. And you can see here from the graph, there's a balance, there's a sweet spot where you reduce variance and bias as well to get the minimum error in your model. And this can be quite challenging. But there's many techniques that we've adapted to help with this problem. Okay, now let me talk about sort of the topic here of the boosting. Is the example of, well, how can we do that using what are called weak learners? A weak learner is a model, can be any model, that performs slightly better than random guessing. So let's say, you have a model that tries to decide between heads or tails of a coin, and maybe if it can predict it with 51% accuracy, that could be an example of a weak learner. Now, that may or may not be possible, but that would be an example, right? So basically, a weak learner is a model that is slightly better than just if we guessed at random, okay? So what's the benefit of a weak learner? Well, the benefit of a weak learner is we have low variance, right? We're not overfit to the data, right? Because we're just slightly better than random guessing. However, the problem is we have high bias, right? So the model is actually underfit, and maybe it's not complex enough to actually model what we're trying to do. So how can we improve on that? So here's an example. So let's take a look at this example where we have yellow and purple dots, okay? And let's say we build a model, we'll call it F1, and we try, F1 is basically a classifier to say, let's try and classify the purple and yellow dots into two categories, okay? So if I'm given a data point with a dot, I try and determine, well, is it yellow or is it purple, okay? So as you can see from this example, F1, the purple dots and the yellow dots, it does a relatively good job, right? There's, of course, a few little errors here, right? But on average, it's better than randomly guessing purple or yellow. So you would say that F1 is a good example of a weak learner, right? Because it relatively is good at classifying both purple and yellow, but not perfect, right? So what we can do is we can take F1, but we could also, and these are examples of the incorrect classification, right? So we can take F1 and we could build another one. We could build F2, okay? So F2 is another model. Now, what is wrong with F2? Well, F2 does a really good job at classifying the yellow dots, right? It's perfect at the yellow dots on the left. However, on the right, there's a number of errors in which it is misclassified yellow dots, right? So again, this could be an example of a weak learner. It's good at classifying yellow, but it's not so good at classifying purple. But we could still potentially use this information, right? So that's another example. And then let's say we take F3, okay? So F3 maybe is really good at classifying purple dots, but not so good at classifying yellow dots, okay? So here's another example. But what we can do in what's called boosting is we can actually combine all of these models together. So as you saw, these models were actually somewhat linear models. You can actually combine them together in a boosted classifier to actually make a nonlinear type of classifier, which is better at modeling this situation. So you see here, FT is actually the sum of all of the different classifiers we built previously. And by doing that, we've actually created a much stronger classifier. So we've optimized our bias and variance parameters, right? So that's an example of what we do at Functionize. Is we take this concept to actually improve upon the models that we use in our production system. So how can we use this? So what we do is we build models for each test case. So every time you build a test case in Functionize, it actually has its own sort of unique model, which is a combination of general models we built before that we've trained across large amounts of data, combined with application-specific models, right, for your application. So the nice thing, there's a lot of general concepts that we see, right? So for example, many people may use like the React framework, for example. So we have models that handle React framework type of situations, right? So we can combine that with application-specific models. So maybe you are, an insurance company and you have very specific business logic around that. So we'll combine those two to actually make an improved model overall that's better for your application and reduces error and bias in the result. So these models basically allow us to create representations of elements and actions for the test case that are much better than building general classifiers or general regression models alone. So that's some of the things we do. So what are the benefits to doing that? Some of the benefits are improved test case maintenance, like I said before. So these models are able to learn over time and can adapt to change, right? Faster test creation. So tests can be created without scripting. So the model itself actually will learn the selectors. It will learn how to perform the actions, right? Using these combined models, these boosted models. And that allows you to create test cases without scripting anything, just basically recording data. And from data, we then model that, in the system to create test cases that, perform much better, right? The other advantage is better analysis. So you can also take this and analyze, for example, trends or anomalies. And this is something else that we do quite frequently is, we'll build a test case or look at a test case, and the test case might pass, but there might be other anomalies in those pages we didn't really look to verify, right? So with machine learning, we can look at huge amounts of data. So not just verifying single elements or single, text on the page, we can actually analyze the entire page and identify anomalies or trends in behavior. So those are some of the advantages to this kind of approach. So with that, that's all I have here today. But now we can take some questions.
Hello, John.
Mm-hmm.
Good afternoon.
Good afternoon.
How are you doing?
Good.
Thank you so much for the presentation.
Mm-hmm.
We're always listening about AI, machine learning, all these big keywords, but it's hard to find someone that actually dives into that and gives us a concrete example on how to put them at work and how they can solve some challenges.
Mm-hmm.
So this was really interesting for me. We already have a couple of questions in the QA tab, but for the audience, you can keep placing those questions there. Starting with a question based on the presentation. So the writer understood that the models will be weak at first, but will increase accuracy while you're using those. That means that the full functionality of the tool will only appear after some time, or can we take advantage of it soon?
Correct. No, that's correct. So the tool will keep improving over time. Now, I will have to say, the general models when we started off were quite weak, but now they actually are quite better, right? Because we've had a lot more training examples that we've collected, right? So don't expect that just starting off the gate, they won't work. A lot of times they will work. But we often see many types of edge cases, many types of situations where, there are examples, things we've never seen before, although it's becoming less and less over time. So there is sometimes some additional training, to actually add in those application-specific models. But I will say most of the time, it will work right out of the gate for most people. Of course, big enterprises have all kinds of complex situations, and that's typically where we see that. But in general, the general models themselves actually are quite good. And we have improved them through boosting over many years, right? Because we've been working on this for over 5 years now. So.
And laughing on that, so not on the question there, but you mentioned in the beginning of the presentation that you could turn manual tests, for example, from Xray into tests that are used by Functionize.
Yes.
How does this process work, and are those tests immediately created for automation? Like, are they scripted? How does that connection?
Correct. So how that works is once your test workflow is defined, you can download we have a Chrome extension called Architect, and you can go through and record. It's basically like a recorder. You can record that test workflow. You don't have to script anything. You just have to go through, click, 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 and you're done. And that's all you have to do. So that's how you would take that manual workflow and actually automate it.
And maybe this next question connects to that. How does the auto-healing work?
How does the auto-healing
work? Is there a possibility that it's fixing tests wrong at first and providing false positives?
Yeah, so there is always a false positive rate. In general, our false positive rate is actually quite low. I think probably maybe 1% or less. So I think typically we'll see maybe an error, maybe like 5 or so out of 1,000, something like that. We do, yeah. So there is sometimes false positives, but that's generally not too big of a problem. So that can happen. So the self-heal itself basically works by learning the page, how it's changed, right? So we look at different changes. So you have the first run of the test versus the second run of the test. We'll analyze the differences, and our model basically will try and solve in a way that a human would think about that change in a way that would be similar to a human tester or manual tester, right? So for example, you might have a login button that changes from red to blue, but it still is login, right? So the color has changed, but actually, in fact, it still is the same meaning, right? It still has the same purpose, right? So we can still identify it. That's just one example. So you could also have a case where the login button goes from the right of the screen to the left of the screen, right? But it's still the login button, things like that. You could change the login button to the sign-in button, right? So language change. So we actually analyze all kinds of different changes and try and adapt to how a human would, interpret that change. And that's basically how the self-healing works.
And so the initial requirement for that test case doesn't change. So if you want to test that, you can press a login button. There can be a lot of changes to that, but the specification itself stays the same during.
Correct. Yeah. So basically, you just need to define with our recorder the workflow, right? What is your test workflow? What are the steps you want to go through? And once that's defined, we will do all that work in terms of trying to figure out, how those XPaths will change or selectors will change, things like that.
And I guess this answers the question on how to solve the tests that are breaking. So with this, you would basically eliminate that almost completely.
Correct. So the objective is to reduce test breakage entirely, right? So once you've created a successful test in Functionize, the first time you've created a successful test, our objective is to make sure that test will always be successful, provided there is no, obviously bug in the system, right? If your site goes down, then clearly the test will fail. But if the site is working as intended, that test case should be maintained and working without any effort from your part, right? So that is the core value we have.
One that's a bit more technical, but what AI/machine learning algorithm is used for building model for object identification and correction?
Yeah. So some of the models specifically for object detection we use are things like convolutional neural networks. So a convolutional neural network is a type of network that uses images. So like we can recognize things like pop-ups. So that's a common case that happens in a test case is you'll be proceeding through the test case. All of a sudden, there's a pop-up alert box that comes up. So we have models that can detect that with 99% accuracy. And then proceed to, remove that alert box or, X out of it, and then proceed with the test case as normal, right? And then we'll identify that there was an anomaly on that step. So we use things like convolutional neural networks to do that.
We don't have additional questions at the moment, at least on the Q&A tab, but I do have one other. So we have been talking mainly about testing things in our browsers, let's say.
Right.
But is it possible to leverage these abilities from Functionize in mobile apps as well?
Yes, it is. Yeah, so we do not host a device farm, but we have actually simulated mobile in a virtual environment. So we can actually simulate, iPhone, Android, that type of thing. So we can actually leverage the same power that we use in website testing in mobile testing as well. And some other interesting things that we can do that I don't know if anyone else in the industry can do is we can actually transport, a test from web into mobile. So like I said, with the login button, right? So let's say you wanted to create a test to test your login functionality. Well, on a mobile device, that layout could be completely different, but that login button will still be there. And those, the username, password fields will still be there in a different format with different selectors, completely different. But we can actually translate that initial website test into a mobile test because the model is able to understand the purpose, the meaning, or the intention of those inputs and buttons. Right?
So in this case, do you use any custom hardware to run the models, or
what was that?
Do you use any custom hardware to run the models?
No. So the models are all run on Google Cloud is our backend. So everything is run in the Google Cloud environment. So we don't have any custom setup for anything. So.
We have a new question. What is the amount of detail that is sent about the executions from Functionize to Xray? Is it easy to understand from either tool what went wrong?
Yes. So we have a results page on our side as well, but we will export all kinds of information, logs and things that happen during the test case to Xray. And depending on what you're looking for, if you're looking for a specific data point, that could be imported, right? But you can see results on both our platform and Xray's platform. Just depends on what you're interested in and what your use case is. So yes.
And is there a trial version that our users could take advantage of for trying out Functionize?
Yes, there is. So we do have a trial. You can go to our website, functionize.com, and you can click sign up, and you can give it a try. So I encourage everyone to look at it and see if it's something useful for you. So.
One more question. So with the architect plugin, the automation engineer business specialist defines the workflow and your AI runs the model from it.
Right.
Does that happen in the cloud only? Is this supervised as well?
Yes. So this does happen in the cloud. We have been working on a version that would run externally all on desktop. So you could actually download the entire thing and run on desktop. That is an option. The problem is that the data analysis required is so large that you're going to want to use the cloud, right? To be able to compute, because so just to give you a sense of data, so we collect, hundreds of attributes per element per page, right? So on average, you'll see about 1,000 elements per page times 400 or something attributes about that element, related to pixels, attributes, class names, all this kind of stuff. So we literally collect millions of data points per page, and then we compute all of that. So that's why we do it on the cloud. But in theory, yes, you could do it on your desktop as an app. But
if you have a supercomputer, or
supercomputer, you'd have to have a pretty powerful computer to do that. Yeah. Otherwise, it'll be very slow. But anyway, yes, it is technically possible.
I don't see any additional questions at the moment, so I'll take this opportunity again to thank you, Jon, for the awesome presentation and the insights that you gave us today. Again, there's a free trial for Functionize that you can take advantage of if you want to. In about 25 minutes, we will have a roundtable for the OmniTesting conference where Sergio Freire and all the speakers will be joining and chatting further about all the topics that were covered in the event. So if you have any additional questions or want to share more of your ideas or maybe use cases with what we learned today, the roundtable can also be a place for that. So again, Jon, thank you very much for joining us today, and hope to see you again.
Great. Thank you very much.
Bye-bye, everyone.